Good morning friends, welcome to the channel Discovery with Data Science. In last video we have discussed about tokenization and we have seen how we have converted a sentence or a word into its vector representation. In this video we are going to discuss what is word embeddings and most commonly used word embedding technique, which is word to vec. So what we have seen in our last video, we have extracted word out of a sentence and then represented it in the form of vector, where we have defined a vector whose length was equal to total number of distinct word in our vocabulary, and to represent, and each word was having its own fixed place inside a vector, and to represent a particular word we will make that place as 1 and keeping rest as 0. But this representation is just a representation of a word as a text, not as a meaning. Word is also having a meaning in it, which depends upon the neighboring words. For example, suppose I say, I love apple fruit and I love Apple laptop. Now in both sentences, if we focus on word apple, its spelling is same. So our vector representation will be the same, but because in first sentence it was used with a neighboring word fruit, so its meaning is different than what is it is used in second sentence where it is used as a laptop. So what is going to be the meaning of apple is decided by what are its surrounding words, or other word we can say it is decided by the context in which it is being used. So no doubt if we want to represent its meaning also, so we have to consider its neighboring words also while creating a vector, and this process is called embedding. The vector we get after the word embedding represents not only its textual representation but as well as meaning also. It conveys meaning of the word also. So there are many methodologies for word embeddings, but most commonly used is word to vec. Here we take help of neural network to create a word embedding vectors. So it's mainly two types: continuous bag of words, and second is Skip-gram model. So as you can see in diagram, both methods uses neural network only, but both are just exactly opposite of each other. Let's begin with continuous bag of word. So suppose I have a sentence, I eat apple every morning, as you can see on. Now suppose I want to find out word embedding of apple, and so far I am considering like apple is represented by a vector representation of tokenization. So what I will do, there is one more parameter that we need to define, that is the window size. Suppose we have taken window size as 2. This means for surrounding words we will take 2 words in the left of apple and 2 words in the right of the apple. Now in continuous bag of word, what we will do, we will take these surrounding words, 2 words of left and 2 words of right, as the input to a neural network, and we will try to predict the word apple in the neural network. As you can see in the diagram, word 1, word 2, word 4 and word 5 are input to the neural network. And remember, when I am saying word 1, word 2, word 4 and word 5, it's not in actual word, it is in its vector representation. the vector representation that we have achieved in the tokenization phase, as you can see in my previous video or part 1 of it. When we try to predict word 3 means apple at output layer, so the weightages of output layer will make our word embedding of word apple. So as you can see, W1, W2, W3 and so on till Wn last weightage. If we will convert this into a vector format, this will be our embedding representation of word apple. Now this method is very simple. Simply in input we have given our surrounding words, and we have tried to predict our target word, and the weightage of the output layer is our word embedding. That's very straightforward, and in performance wise also this is very lightweight and accurate than the second one that we are going to discuss. The second one is Skip-gram model. Now here I am doing just opposite. I am taking word 3 means my target word, which is apple, as input, and I am trying to predict our surrounding words. I am trying to predict word 1, word 2, word 4 and word 5. And weightages of the middle layer in the continuous bag of word method, weightages we have considered for the output layer, but here weightages are for middle layer. These weightages, when given in the vector form, they represent our word embedding for the apple word as per Skip-gram model. Now this method is not as efficient as our previous one, continuous bag of word method, but still we use in the places where we have sample set is very less, because in that case it performs better than continuous bag of word. For example, there may be few words or few phrases that are not used very frequently, so we cannot get ample amount of sample set for that word. So to train that, continuous bag of word will not give accurate results than Skip-gram model. Otherwise it is not as efficient as previous one, continuous bag of word method.